हेलो स्टूडेंट्स, આવી ગયો તમારો उस सबको भूल जाओ, पढ़ने में ध्यान दो। चैप्टर 3 करंट इलेक्ट्रिसिटी इलेक्ट्रोमोटिव फोर्स। आज का टॉपिक क्या है? इलेक्ट्रोमोटिव फोर्स। लास्ट टाइम वी हैव स्टडीड अबाउट सीरीज एंड पैरेलल कनेक्शन ऑफ रेजिस्टर्स। इलेक्ट्रोलाइटिक सेल consists of two electrodes called positive electrode, negative electrode and electrolyte and an electrolyte. टॉपिक है इलेक्ट्रोमोटिव फोर्स EMF. दिस टॉपिक इज रिलेटेड टू सेल और बैटरी. इलेक्ट्रोलाइटिक सेल consists of two electrodes. How many electrodes? Two electrodes, positive electrode and negative electrode, and it consists of an electrolyte. When the electrodes are immersed in electrolyte, when these two electrodes are immersed in electrolyte, electrolyte is nothing but that is chemical solution, they exchange charge carriers with the electrolyte. They exchange charge carriers with electrolyte. The positive electrode has a potential difference V plus. This positive electrode has potential difference V plus between itself and the electrolyte solution adjacent to it. It means potential difference between this electrode and this electrolyte marked as A has potential difference V plus. It means in comparison to this electrode has positive potential. So potential difference that is positive between this electrode and this electrolyte adjacent to it. Similarly, the negative electrode develops a negative potential minus V minus relative to electrolyte adjacent it. Potential difference between this electrode and electrolyte that is minus V minus. It has positive potential in comparison to electrolyte, it has negative potential in comparison to this electrolyte adjacent it. When there is no current, the electrolyte has same potential throughout. When no current is flowing through this cell, at that time this electrolyte has same potential throughout. Potential that is same. Here positive, here negative, electrolyte has same potential throughout, so that the potential difference between P and N, potential difference between these two electrodes that is P and N is, what is the potential difference? Here potential difference that is V plus, and here potential difference that is minus V minus. So potential difference between P and N is V1 minus V2. So V plus minus minus V minus. So potential difference that is minus minus plus. So V plus plus V minus. So potential difference between P and N is V plus plus V minus. This difference is called the electromotive force. This difference of potential between P and N is called electromotive force of the cell and is denoted by E. So formula of electromotive force EMF is E is equal to V plus plus V minus. About EMF already you have studied in chemistry. Chemistry में आपने EMF के बारे में पढ़ा है. EMF is nothing but potential difference between these two electrodes, that is V plus plus V minus, when no current is flowing through this electrolyte. In open circuit condition, whatever is the potential difference between two electrodes, that is nothing but EMF of the cell. So this way we can find electromotive force. From this we can say that electromotive force is potential difference and it is not a force. From this it is clear that electromotive force that is potential difference, it is not a force. नाम पे से ऐसा लग रहा है EMF क्या है? फोर्स, पर EMF फोर्स नहीं है. EMF क्या है? पोटेंशियल डिफरेंस. EMF is actually work done in moving unit positive charge from negative terminal of the battery to the positive terminal. So that is nothing but kind of energy. EMF is a kind of energy. EMF is not a force. EMF is actually source of energy, जिसकी वजह से चार्ज मोशन में आता है. What is the SI unit of EMF? What is the SI unit of EMF? As I told you, EMF is nothing but work done in moving unit positive charge from negative terminal of the battery to the positive terminal is called EMF. तो EMF हुआ E is equal to work done per unit positive charge. What is the unit of work? Joule. What is the unit of charge? Coulomb. So joule per coulomb is the unit of EMF. तो EMF का यूनिट क्या हुआ? जूल पर कूलम. याद हो तो जूल पर कूलम हम पढ़ चुके. जूल पर कूलम इज नथिंग बट वोल्ट. सो वोल्ट इज द यूनिट ऑफ EMF because EMF is nothing but potential difference. And what is the unit of potential difference? That is volt. ऐसा यूनिट ऑफ EMF is volt. EMF क्या है? That is electromotive force. And electromotive force is not a force, that is potential difference. SI unit of EMF, that is volt. A current I flows across R from C to D. If we connect any conductor which is having resistance R with this cell, then what will happen? Current will flow through it. And we know that current flows from higher potential to lower potential. This is a higher potential and this is lower potential. So current will flow from higher potential to lower potential like this. So current is flowing from C to D in this direction across this resistance R. A steady current is maintained because current flows from N to P through the electrolyte. A steady current is maintained because current flows from N to P through the electrolyte. What does it mean? From this you can see this is the electrolytic cell. This is positive terminal, this is negative terminal, and current is flowing in this direction like this. Inside the battery, current is flowing from negative terminal to positive terminal. Outside the battery, current is flowing from higher potential to lower potential. ध्यान से देखो. Steady current is maintained because current flows from N to P through the battery. अंदर जो है करंट फ्लो हो रहा है वो कहाँ से फ्लो हो रहा है? नेगेटिव टर्मिनल टू पॉजिटिव टर्मिनल थ्रू दिस इलेक्ट्रोलाइट. So here current is flowing from negative terminal to positive terminal inside the battery, inside the electrolytic cell. बाहर कैसे फ्लो हो रहा है? पॉजिटिव टू नेगेटिव. अंदर कैसे फ्लो हो रहा है? नेगेटिव टू पॉजिटिव. दैट इज वाई अ स्टेडी करंट इज मेंटेन. अगर यहाँ पे भी पॉजिटिव टू नेगेटिव फ्लो होता तो करंट की डायरेक्शन चेंज हो जाती. whenever there is a closed loop then current will flow in this manner, higher potential to lower potential outside the battery. मतलब बाहर जो भी कनेक्ट किया है, रजिस्टर कनेक्ट किया हुआ है, वायर कनेक्ट किया हुआ है, उसमें करंट कैसे फ्लो होने वाला है? हायर पोटेंशियल टू लोअर पोटेंशियल. बट इनसाइड द बैटरी करंट फ्लोज फ्रॉम नेगेटिव टर्मिनल टू पॉजिटिव टर्मिनल N to P through the electrolyte. The electrolyte through which a current flows has a finite resistance R. अब इसमें से करंट फ्लो हो रहा है और अंदर क्या यूज़ किया है? कुछ केमिकल. जो केमिकल यूज़ किया है उसका भी कुछ रेजिस्टेंस तो होगा. एवरी मटेरियल हैज सम रेजिस्टेंस. कंडक्टर होगा तो उसका भी कुछ रेजिस्टेंस होगा. यहाँ पे केमिकल यूज़ कर रहे हैं तो उसका भी कुछ रेजिस्टेंस होगा. सो द इलेक्ट्रोलाइट थ्रू विच अ करंट फ्लोज हैज़ अ फाइनाइट रेजिस्टेंस R. कुछ अमाउंट का तो रेजिस्टेंस होगा, और उसे क्या बोला जाता है? दैट इज कॉल्ड इंटरनल रेजिस्टेंस. That is called internal resistance. So whatever is the resistance of the electrolyte, that is denoted by small r, and that resistance is called internal resistance of cell. This is external resistance which we have connected, and this is the internal resistance of the battery. Consider first the situation when r is infinite, so that मान लो कि r की वैल्यू क्या हो जाए? बहुत बड़ी, very large value of r. If r tends to infinite, then according to Ohm's law, I is equal to v by r. If r tends to infinite, then electric current will become 0. So I is equal to 0, where v is the potential difference between p and n. But what is potential difference between p and n? The potential difference between p and n is nothing but EMF E. So in open circuit condition, potential difference between p and n is nothing but EMF E. When current flowing through the cell is 0. When electric current becomes 0, open circuit condition. Here if you remove the contact, then no current will flow through this, and this condition is called open circuit. कनेक्शन है ही नहीं तो सर्किट कैसी हो गई? ओपन. क्लोज सर्किट है नहीं, क्लोज पाथ है ही नहीं, तो करंट आगे जाएगा ही नहीं. अगर करंट 0 हो गया तो उस समय पे पोटेंशियल डिफरेंस बिटवीन दिस टू टर्मिनल्स, पॉजिटिव टर्मिनल एंड नेगेटिव टर्मिनल, इज नथिंग बट EMF E when current is 0, and that condition is called open circuit condition. But the situation will be different when we consider closed condition. When we consider closed circuit condition, closed circuit condition consider करूँ तो करंट की वैल्यू 0 नहीं होगी. At that time value of resistance will not be infinite. There will be some finite value of resistance. So if R is finite, then what will happen? जैसे ही करंट फ्लो होगा तो करंट सिर्फ बाहर नहीं फ्लो होने वाला है. दैट करंट विल फ्लो फ्रॉम N to P. दैट करंट विल फ्लो फ्रॉम N to P थ्रू द इलेक्ट्रोलाइट. और जैसे ही अंदर करंट फ्लो हो रहा है नेगेटिव टर्मिनल टू पॉजिटिव टर्मिनल, एट दैट टाइम देयर विल बी सम पोटेंशियल ड्रॉप बिकॉज ऑफ दिस इंटरनल रेजिस्टेंस. करंट फ्लो करवाने के टाइम क्या करना होता है? चार्ज को मोशन में लाना है, और अंदर कुछ रेजिस्टेंस है. व्हाट इज द प्रॉपर्टी ऑफ रेजिस्टेंस? रेजिस्टेंस इज अ फिजिकल क्वांटिटी विच ओपोजेस द मोशन ऑफ इलेक्ट्रिक चार्जेस. तो वो तो ओपोज करने वाला है. तो चार्ज को यहाँ से यहाँ पे मूव करवाने में कुछ एनर्जी कम हो जाएगी. यस और नो? रेजिस्टेंस जहाँ पे भी होगा उसकी वजह से एनर्जी कम हो जाएगी. तो इंटरनल रेजिस्टेंस की वजह से पोटेंशियल डिफरेंस पहले कितना था? करंट फ्लो 0 था, I 0 था, तो पोटेंशियल डिफरेंस क्या था? EMF E. और E क्या है? V प्लस प्लस V माइनस. ये EMF था. जैसे ही करंट फ्लो होगा तो चार्ज को यहाँ से यहाँ पे लेके जाने में कुछ एनर्जी खर्च हो जाएगी. सम अमाउंट ऑफ वर्क इज रिक्वायर्ड टू बी डन इन मूविंग चार्ज फ्रॉम दिस टर्मिनल टू दिस टर्मिनल. एट द टाइम पोटेंशियल डिफरेंस between these two terminal, V is equal to V plus V minus IR. This V is the potential difference between two terminals. Therefore this V is called a terminal voltage. इसे क्या बोला जाता है? टर्मिनल वोल्टेज. But what is V plus V minus? V plus V minus is nothing but EMF E. So instead of this V plus V minus, we can write EMF E minus IR. Equation number 1. Why we have taken negative sign? Because some amount of energy is spent in moving charge from negative terminal to positive terminal through this electrolyte, because this electrolyte offers some internal resistance. ये एनर्जी यहाँ पे खर्च हो जाती है, कम हो जाती है. जो एनर्जी सेल की थी जब करंट फ्लो नहीं हो रहा था उससे कम हो जाती है. इसकी वजह से यहाँ पे क्या है? माइनस. एक्चुअली करंट का फ्लो कैसे होना चाहिए? पॉजिटिव टू नेगेटिव. पर करंट कैसे फ्लो हो रहा है, नेगेटिव टू पॉजिटिव, दैट इज वाई हियर वी हैव टू पुट नेगेटिव साइन. इनसाइड द बैटरी करंट फ्लोज फ्रॉम नेगेटिव टू पॉजिटिव. In practical calculations, internal resistance of cells in the circuit may be neglected. Internal resistance of the cell may be neglected when the current I is such that, when product of these two is such that EMF is much greater than IR. If the value of EMF is much greater than IR, then we can neglect this term. We can neglect the value of internal resistance when EMF is very large. So in open circuit condition, if terminal voltage is very large, then we can neglect the value of internal resistance. At that time internal resistance of cells in the circuit may be neglected. तो उसमें internal resistance को consider करने की कोई ज़रूरत नहीं है. But every cell has some internal resistance. And value of internal resistance vary from cell to cell. जैसे सेल बदल जाएगा तो उसकी इंटरनल रेजिस्टेंस की वैल्यू बदल जाएगी. तो अलग अलग सेल्स के लिए अलग अलग इंटरनल रेजिस्टेंस होता है. वी ऑल्सो ऑब्जर्व दैट सिंस V is potential difference across R, whatever is the potential difference between P and N, whatever is the potential difference between these two terminals of cell, same is the potential difference across two ends of resistance R. That is nothing but, and this battery has EMF E. So potential difference across R is nothing but V is equal to IR. According to Ohm's law, V is equal to IR. So we can write V is equal to IR. So terminal voltage is nothing but I into R. Equation number 2. From equation 1 and 2, substitute the value of V in this equation. Then we can write IR is equal to E minus IR. क्या लिख सकते हैं? IR is equal to E minus IR. If we make E subject, then IR plus IR. What can we take common? I. R plus R. Amount of current flowing through this circuit, that is I, is equal to EMF E upon R plus R. This is nothing but Ohm's law. I is equal to V by R. What is E? That is EMF of battery upon total resistance. What is the total resistance of this circuit? Value of external resistance, that is capital R, and value of internal resistance, that is the resistance of battery, that is small r. And as I told you, when EMF is much greater than IR, at that time we can neglect this value of internal resistance. So this way we can find value of electric current flowing through the circuit. In open circuit condition, terminal voltage is equal to EMF, and in closed circuit condition, value of terminal voltage is always less than value of EMF. आप देख सकते हो, when closed circuit we are considering, at that time some current will flow, and due to that current flow some potential drop will be there due to this internal resistance, and terminal voltage decreases by this amount. So potential, that is potential between two terminals, terminal voltage, potential difference between two terminals, that is nothing but terminal voltage, is always less than EMF when current is flowing through the circuit. One thing we should notice here, the cell will discharge. सेल डिस्चार्ज होता जाएगा. जैसे कि आपकी कार की बैटरी है, उसे यूज़ करेंगे तो सेल डिस्चार्ज होगा. एक्टिवा की बैटरी है, बाइक की बैटरी है, उसे यूज़ करेंगे तो क्या होगा? सेल डिस्चार्ज होगा. अगर सेल डिस्चार्ज हो चुका है तो उसे रिचार्ज करवाना हो तो क्या करेंगे? हमें उससे ज़्यादा अमाउंट की बैटरी उसके साथ कनेक्ट करनी पड़ेगी. इन चार्जिंग कंडीशन, when we are charging the cell, at that time terminal voltage V is equal to E plus IR. तब क्या होगा? E plus IR. मतलब इस इलेक्ट्रोलाइटिक सेल के साथ कोई और बैटरी कनेक्ट की जाए जिसका EMF इससे ज़्यादा हो, तब टर्मिनल वोल्टेज इसका क्या हो जाएगा, E प्लस आई आर, क्या हो जाएगा, E प्लस आई आर. Otherwise the formula of terminal voltage is E minus IR. So whenever we want to run any device through this electrolytic cell, at the time V is equal to E minus IR. Whenever we are using battery or cell in any circuit and due to that circuit is working, then terminal voltage is equal to E minus IR. अब हम मैकेनिज्म समझेंगे. यहाँ पे ईएमएफ का फंडा क्लियर हो गया कि ईएमएफ क्या है. ईएमएफ दैट इज नथिंग बट पोटेंशियल डिफरेंस बिटवीन दिस टू टर्मिनल्स P and N when no current is flowing through the circuit. In open circuit condition, whatever is the potential difference between P and N, that is nothing but EMF. EMF ये कब होगा पोटेंशियल डिफरेंस बिटवीन P and N, जब ओपन सर्किट कंडीशन होगी, करंट जीरो होगा. जब करंट फ्लो होगा तब ये दोनों की वैल्यू सेम होगी नहीं, तब यहाँ पे जो पोटेंशियल डिफरेंस होगा वो EMF से थोड़ा कम होगा. कितना कम होगा, माइनस आई आर. EMF से कितना कम हो जाएगा, E माइनस आई आर. सो दिस मच अमाउंट ऑफ टर्मिनल वोल्टेज वी विल गेट. This is called terminal voltage, this is called EMF, this is electric current, and this is internal resistance, and this is external resistance which we have connected. Now we will understand the mechanism of EMF. Here I have considered some marbles which are in motion. They are moving like this. They are at certain height first and they are moving in this direction. They reaches to the ground. Once they reaches to the ground, there isn't any other path to go back to the top. इसको यहाँ से ऊपर लेके जाया जा सकता नहीं है, अपने आप तो कोई यहाँ से जाने वाली नहीं है. बिकॉज टू कंटिन्यू द मोशन ऑफ दिस मार्बल्स, what we have to do, some amount of work is required to be done. यहाँ पे जो ये इंसान खड़ा है उसे यहाँ से मार्बल को ऊपर लेके जाना पड़ेगा. अमाउंट ऑफ वर्क डन पर मार्बल, अमाउंट ऑफ वर्क डन पर मार्बल इन टेकिंग इट फ्रॉम ग्राउंड टू दिस हाइट इज नथिंग बट EMF ऑफ दिस मैन. सेम थिंग इज हैपनिंग हियर. मैकेनिज्म कुछ ऐसा ही है. यहाँ पे चार्ज मोशन में है, यहाँ पे मार्बल मोशन में है. मार्बल कहाँ पहुँचे, नीचे, तो ऊपर लेके जाना है. चार्ज कहाँ पे पहुँचा, यहाँ पे. यहाँ से यहाँ पे लेके जाना है. फ्रॉम दिस लोअर पोटेंशियल एनर्जी टू हायर पोटेंशियल एनर्जी, लोअर पोटेंशियल एनर्जी टू हायर पोटेंशियल एनर्जी. देन सम अमाउंट ऑफ वर्क इज रिक्वायर्ड टू बी डन. सो वट एवर वर्क इज डन इन टेकिंग यूनिट पॉजिटिव चार्ज फ्रॉम this terminal to this terminal is called EMF. Therefore work done per unit charge is called EMF. Therefore unit of EMF is joule per coulomb and that is called volt. Same way work done in taking this marble from here to here is nothing but EMF of man. So work done per marble is nothing but EMF of this man. This way we can understand the concept of EMF. तो आशा रखता हूँ कि आपको EMF का कंसेप्ट समझ में आ गया होगा. EMF में क्या चीज़ें ध्यान रखेंगे, EMF में हमें ध्यान रखना है, एक सेल कंसीडर करना है. उस सेल को पहले किस में रखेंगे, ओपन सर्किट कंडीशन में. व्हेन वी आर कंसीडरिंग ओपन सर्किट कंडीशन, एट द टाइम नो करंट विल फ्लो, एंड व्हेन नो करंट फ्लोज थ्रू द सर्किट, एट द टाइम वट एवर इज द पोटेंशियल डिफरेंस बिटवीन टू टर्मिनल्स, दैट इज नथिंग बट EMF E. When we connect some external resistance with the battery, then what will happen, some current will flow. When current starts flowing, at the time terminal voltage decreases and formula of terminal voltage will be E minus IR. Because this electrolyte offers some internal resistance. Due to this internal resistance there will be some potential drop when we are considering closed circuit. In open circuit condition, whatever is the potential difference between these two terminals, that is same as EMF. When we consider closed circuit, at that time this terminal voltage, that is potential difference between these two terminals, is less than EMF. current flowing through the circuit is nothing but EMF E upon R plus R. This R is called internal resistance, E that is EMF, I that is electric current, and R that is external resistance. Value of internal resistance will be different for different cells. So EMF is nothing but potential difference between P and N when no current is flowing through the circuit, when there isn't any current flow. Or we can say that EMF is nothing but amount of work done in taking unit positive charge from negative terminal to positive terminal is called EMF. Unit of EMF is nothing but joule per coulomb or volt. तो आज का ये टॉपिक EMF आपको क्लियर हो गया होगा. आशा रखता हूँ कि EMF का कॉन्सेप्ट आपको समझ में आ गया होगा. नेक्स्ट टाइम वी विल स्टडी अबाउट सेल्स इन सीरीज एंड सेल्स इन पैरेलल. विद दिस आई एम एंडिंग टुडेज लेक्चर. मिलते हैं नेक्स्ट लेक्चर में. बाय बाय. थैंक यू.